this tutorial. Today we did a model of the composite column under the compression test. You can see here we use a composite column with 3 layers. The first layer, red, is wood. Here is ultra high performance concrete, and the outer cover is the steel material under the, you can see, under the compression test. Let's remove this and click on animate. You can see here this is the stress. Let me check it in this view, and let me first replace, this is the concrete. This is the ultra high performance concrete stress. We have compression damage for this. You can see it is failed completely. Tension damage, see the tension damage, or the stiffness degradation, or the plastic strain. And now let me replace all, and here we can, from here, select the wood, replace. Here is the wood plastic strain, the stress, displacement, or anything else. And the last thing is the steel cover. This is the cover, stress, ductile damage, plastic strain, or anything else. So this is the first model. In the second model, we use damage as the strain damage for the ultra high performance concrete. See here the damage in the model 2. Let me remove this and check it in this view. Click on this, and you can see everything has changed. See the deformation of the steel cover, the concrete, anything else. Let me replace first the steel. Here the deformation is changed. See the deformation, and local buckling happened, and you can see the ductile damage, the plastic strain, or anything else. And now let me replace the ultra performance concrete. Here this is the concrete and the damage which has happened. Click on animate. See under the compression test the column is failed here. See here is failed. And now let me check the compression damage, the tension damage, the stiffness degradation, or anything else. Now let me replace the wood. The wood requests the stress, plastic strain, or anything else. And here is the full model that when we use the strain damage as input file. So there are many different between the graphical results like this and the previous model. Also in both we drew the force displacement diagram. You can see the red is the model with damage, strain damage, and the second is the model without strain damage. See, till here both diagram is the same, but after this we have a decreased capacity in the column with a strain damage method here, but here we didn't use that, and the stiffness still exists in the model, but here not. The model failed rapidly here because of the concrete element deletion. Okay, this is the difference between two diagrams. So if you need to model concrete with strain damage behavior or without that, wood with elastic plastic model, also the steel material with the damage model, you can come to our website here. The website www.abaqusfem.com. Here find the English tutorials, click on title or blue sign, then you will have the title, part definition, assembly, material model, step interaction load, and the result as figures. You can see them here. The cost for the CAINP English video file step by step is 30 euros. You can use a PayPal account, a Visa or MasterCard for the payment. Contact me to this email to tell you about the tutorial and if you need any question, also the payment method. And besides this tutorial, we have the full package contains around more than 400 tutorials about all things in Abaqus modeling and simulation, from the research papers, from the books, anything. And you can check here the subtitles, sorry, the main titles of the package here. These are the main titles. We have a lot of subtitle in these main titles. You can read them here. And for each file, we have CAINP English video and paper, and you can buy that with a good price. So, if you need this full package, contact me on this email. Thank you for your